Hello, my name is Bryce Hill. This video we're going to be going over basic geometric shapes. Here's our supporting text. This class is for geometry, Georgia State University, spring semester 2001. Title to our video is to compare, contrast, and distinguish common 2D shapes. We get that from our Bloom right here. Our first video, we went over remember and understand. Our second video, we went over to apply, where we had the students sketch some of the common 2D shapes. Now we're up to the middle with analyze, where we're having the students to compare, contrast, and distinguish the common two-dimensional shapes. Here's our Georgia standard. We are to find area of the right triangles and other triangles, quadrilaterals, and polygons by composing them into squares or decomposing into triangles and other shapes, applying these techniques in context of solving real-world and mathematical problems. And here's our Common Core standard. For transfer, students will be able to independently use their learning to compare, contrast, and distinguish the basic components of all geometric shapes, which are the point, the plane, line, and angle. Barriers to this goal: students may not be able to access the computer, Microsoft Office, Google Docs, or other software that we use to present the learning. Students may not understand some of the abstract concepts. Here are the essential questions. Students will keep considering what are the defining relationships between a point, line, line segment, ray, or angle. Students will keep considering what rules distinguish geometric shapes from each other. Students will keep considering under what conditions can an angle be defined as a line. Students will keep considering if any geometric figures can be defined without points. Students will keep considering how are spatial relations, including shapes and dimensions, used to draw, construct, model, and represent real situations or solve problems. Students will keep considering what are the mathematical attributes of objects and how are they measured or calculated. Understanding. Students will understand that geometry can effectively describe naturally occurring patterns. Students will understand that identifying the properties of simpler components of geometric figures can help understand the composition, design, and properties of more complex geometric figures. Students will understand that one geometric figure can be used to generate another. Students will understand that there is more than one way to represent and understand relationships between geometric figures. Students will understand that some geometric figures can be identified by multiple terms. Students will understand that two geometric figures can be added to create another. Students will understand that two geometric figures can be subtracted to create another one. Knowledge. Students will know that lines and line segments are made up of at least 2 points. Students will know that lines and line segments have midpoints that divide the figures equally. Students will know that angles are made up of 2 rays that share an endpoint. Students will know that points, line segments, rays, and angles are used to make more complex geometric figures. Students will know that acute angles are less than 90 degrees. Right angles are 90 degrees. Obtuse angles are over 90 degrees. And straight angles are 180 degrees. Skills. Students will be skilled at identifying the components that make up simple and more complex geometric figures. Students will be skilled at building geometric figures by knowing how to connect points, which are then connected to line segments or rays. Students will be skilled at identifying a line segment, line, ray, or angle by definition, labeling, illustration, or symbols. Students will be skilled at identifying acute, right, obtuse, and straight angles. We will begin this lesson with a pre-assessment. This way we'll be able to gauge what level of prior knowledge the students are bringing into the lesson. Here's the link here. Here's one of the first questions. Geometry is based on these undefined words, which are plane, points, lines, or all of the above. A plane has infinite number of points. However, how many points are needed to define a plane? If line segment AM is the same length as line segment MB, then both sides are said to be congruent, the same, equal distance, all of the above. A line has an infinite number of points. However, how many points are needed to define a line? At least 1 point, 2 points, at least 3 points, at least 4 points. Angles whose measures are 180 degrees are said to be acute angles, right angles, obtuse angles, or straight angles. Explain. Have students explain how simple components such as points, line segments, lines, rays, and other angles can be used to create more complex geometric shapes. Now we ask the students, what do you need to make every geometric figure? But the answer is points. Points. A geometric figure that has position but no length, width, or depth. You want to have the kids understand that all geometric figures are composed of points. And now we ask more questions. A flat surface extending indefinitely far in every direction that has length and width but no depth. A plane, a point, a line, a ray. Wait and see if the kids can answer. And we give them the answer, which is plane. A flat surface extending indefinitely far in every direction, has length and width but no depth. At this point you might want to use a table or a sheet of paper to show what a plane is. What do you need to create a plane? Points are needed to create a plane. A plane has an infinite number of points. However, how many points are needed to define a plane? At least 1, at least 2, 3 points, or 4 points? Answer. It takes at least 3 points to define a plane. Any 2 or more points that are on the same plane are said to be coplanar, cooperative, collinear, or coefficient. And let the students answer. Coplanar. Any 2 or more points that are on the same plane. Next question. Any 2 or more lines that are on the same plane are called cooperative, coplanar, coefficient, collinear. Give the students time to answer. The answer is coplanar. Any two or more lines that are on the same plane. Next question. A geometric figure that is made up of at least 2 points. It has no width or depth, yet extends to infinity in both directions. Is this a point, a plane, a ray, or a line? Give the students time to answer. The answer is a line, which is a geometric figure that is made up of at least 2 points. It has width or depth, yet extends to infinity in both directions. Next question. What do you need to create a line? Now we go back to our concept map to show the comparison. We begin with points. We have planes within those points. Now we have lines, so you need points and a plane to create a line. Any two or more points that are on the same line are called collinear, cooperative, coplanar, coefficient. Wait and allow the kids to answer. Collinear. Any two or more points that are on the same line. A figure formed by two rays with a common endpoint. A degree, sides, angle, line segment. Allow the children to answer. Angle, which is formed by two rays with a common endpoint. The common endpoint is called the vertex. The rays are also called sides. Here's an example. Moving on to our next essential question. Can we draw an angle without two rays? And here we try to figure out to compare, contrast, and distinguish. We go back to our concept map. We begin with points, because we can't have anything without a point. Points define the plane. We have the lines, which are we can't have without being on the plane, and we can't define without the point. Now we have the angles, which we need points, planes, and lines to create the angles. Next question. Angles whose measures are 180 degrees are called acute angles, right angles, obtuse angles, or straight angles. Allow the students to answer. This is a straight angle, and as the diagram shows, you don't need two rays. You could just draw a straight line to make a 180 degree angle. Now to draw more connections, we have the compare and contrast where we ask these essential questions again. Use a discussion format. Remind students of key words in the definitions and diagrams from the lesson in answering these questions. To compare, what features are shared by planes, lines, and rays? Contrast. What features make planes and lines different? Contrast. What features make lines or rays different? Compare. At what time can an angle be defined as a line? You can differentiate this lesson by having students find real-world applications for what they've learned in the lesson. For example, a map. Points can identify location or points of interest on a map. Lines can connect location, points on a map. Rays show cardinal directions, such as north, south, east, and west. Angles can give us an orientation from starting points, 20 degrees northwest. Plane holds everything together. For an evaluation, you can have the kids take this post lesson, which is here. Feel free to copy this lesson if you want to and save it in your own Google Docs. Here's our reference page.